This is the lecture for lesson 31. In this lesson, we are going to solve log equations. So we will use the definition of a log to solve them. We will use log properties to solve them, as well as the one-to-one property of logs to solve them. For the first problems, we're just going to use the definition of the log and how it translates to an exponential to be able to solve these basic log equations. So we need to remember that log of BA equals E turns into base to the exponent equals the answer. So if I take A, I have log base 2 of x equals -5. So the base is 2. The exponent is then the -5, and the answer is x because it's base, answer, exponent. And then I can just figure out what is 2 to the -5th. Well, 2 to the -5th is 1 over 2 to the 5th, which is 1 over 32. And that is the answer. Working with B, we have log base 5 of x minus 8 equals 2. So base, answer, exponent. So the base is 5, the exponent is 2 equals the answer, x minus 8. Well, 5 squared is 25. If that is equal to x minus 8, and I want to solve for x, I'm just going to add 8 to both sides and get that the answer is 33. And then for C, we have 6 natural log of x equals 30. So the first thing I'm going to do is I want to get rid of that 6 here. So I'm going to divide by 6 on both sides. Natural log of x equals 5. Now we need to remember natural log of x is like saying I have log base e of x equals 5. So base, answer, exponent. So if I translate this over, e to the 5th power equals x. And I'm just going to leave it like that. You could go and find the decimal if it wanted you to, but for this one, I'm just going to leave it as that. All right, so these next problems, we're going to need to employ one of our log properties first before we can turn into exponential form. So we see we have this first problem here, log base 4 of x minus 1 plus log base 4 of x plus 1 equals 3. And if you remember our properties, they say if we add outside of a log, we can multiply the pieces inside of the log. So that's going to be x minus 1 times x plus 1 is still equal to 3. So on the side, we could FOIL this out. We get x squared plus x minus 1. So that turns into x squared minus 1 because the plus x and the minus x end up canceling each other out. So I have log base 4 of x squared minus 1 equals 3. Once you have a single log, you can then turn it into exponent form. So base, answer, exponent. So base, answer, exponent, we are going to then turn it into 4 to the 3rd equals x squared minus 1. Well, 4 to the 3rd is 64. So 64 equals x squared minus 1. I need to add 1 to both sides. So I'm going to get 65 equals x squared. And then to get x by itself, I'm going to square root. So x is going to equal the square root of 65. One thing you should always do is double check your answer. I need to always have a positive in a log. So I know we didn't check that on the first ones. I promise they did all work. But whatever you put inside the long here must be a positive. So if I go back, the square root of 65 is a positive. That's clearly bigger than 1. The square root of 65 minus 1, that's going to stay positive, and that's going to be positive. So this will work. If by chance the number I get is negative, or it makes one of these pieces negative, then that answer is not a solution, and there is no solution for the problem. So I did forget to check that on the front slide. I apologize, but do know that moving forward, we will always double check that our solutions work. All right, so B, we have log of 2x minus 1 minus a log of x equals 2. So I have two logs that are being subtracted currently. Subtraction outside a log means division inside of the log. So that's log of 2x minus 1 all over x equals 2. Now, there is no base listed because this is a common log, and that common log base is 10. So this is log base 10, 2x minus 1 over x equals 2. So base is 10, answer exponent. So 10 squared equals 2x minus 1 all over x. Well, 10 squared is 100. 100 equals 2x minus 1 over x. I'm going to put the 100 over 1 so that I can cross multiply here. 100 times x is 100x. And 1 times 2x minus 1 is 2x minus 1. Okay, so then to get the x's together, I'm going to subtract 2x. I have 98x equals negative 1. And then I'm going to divide by 98. So I get x equals negative 1 over 98. So first thing I see is this is a negative, so I need to be sure that I double check this. If I plug this back in here, it's going to say do the log of negative 1 over 98. You can't do that. Logs can only be evaluated for positive numbers. It does not work for negative numbers. So even though we did all of this work, this is not a solution, and we in fact have no solution for this problem. Next one, we have log base 6 of x plus 5 plus log base 6 of x equals 1. So we have addition of logs. So that means I'm going to multiply their insides. So log base 6 of, I'm going to put the x in front, x times x plus 5, just because that's the way we normally see to multiply them. So if I multiply that through, log base 6 of x squared plus 5x is equal to 1. Single log, so base, answer, exponent, I'm going to go to my exponent form. So 6 to the first power equals x squared plus 5x. All right, so we have an x squared though, so we need to get everything to the one side and see if we can factor this. So I'm going to move this 6 over. So I have 0 equals x squared plus 5x minus 6. So now we're going back to the very beginning stuff that we did. How do we factor these? We are looking for two numbers that multiply to negative 6, and those same two numbers add to 5. Now you need to be careful here. It is not 3 and 2. Okay, there's no way to use a 3 and a 2 with one of them being negative to get that negative 6 to get me a positive 5 when I add. The pair here is 6 and 1. And that is a negative 1. 6 times negative 1 is negative 6. 6 minus 1 is 5. So that's going to make x minus 1 and x plus 6 as our factors, meaning that if we solve each of these, x minus 1 equals 0, x plus 6 equals 0, we get the answers of x equals 1. And on this one, if I subtract 6, x equals negative 6. So always double check. So let's plug in 1. 1 plus 5 is 6. 1, both of those are positive. That one works. If I use negative 6, negative 6 plus 5 is a negative 1 inside of the log. Uh-oh, can't use that one. So the only solution for this is the x minus 1. Which is why we have this question here for number 3. What should always be your last step when solving these log equations? And you should always check your answer in the original problem, okay? The log value here has to be positive. If you get this, that is not a solution. It will not work. We have one more property here with logs, and it tells me that if I have a log on one side and a log on the other side with the same base, then what's left has to be equal. So here it says if log base b of s equals log base b of t, then s has to equal t. So as long as I have a single log on both sides, I can use this property. Well, if we look at a, log base 2 of x minus 5 equals log base 2 of 4. What that means is just like what we did with the exponents. If the exponent base was the same, we set the powers equal to each other. So if the log pieces are the same, we set the remainders equal to each other. So this is just going to be x minus 5 equals 4. And to solve, I will add 5 to both sides and get the answer of 9. I can plug that in. 9 minus 5 gives me a positive 4. Boom. Okay, for b, log of x plus 3 equals log of x plus log of 3. Well, I don't have a single log on both sides yet, but I know that I can combine the logs on the right-hand side. So if I leave the left-hand side alone, log of x plus 3. If we add logs on the outside, we can multiply their inside. So log of x plus log of 3 is log of x times 3, or 3x. And now they are both logs, so we just work with what's left. X plus 3 equals 3x. So I will subtract x from both sides. Pull it over here. I have 3 is equal to 2x. And when I divide by 2, x is equal to 3 halves. If I plug that back in, that's a positive. A positive plus a positive is going to keep that positive. And that one's a positive there. So I know that one is, in fact, a solution. Okay, next one. Natural log of x plus 3 plus natural log of x minus 2. So addition outside means multiplication inside. So x plus 3 times x minus 2 equals natural log of 14. So if I multiply these out, FOIL it out here, I will get x squared. I'm going to get minus 2x and plus 3x, which is going to make plus x. And then 3 times negative 2 is negative 6, equals natural log of 14. Both have the same log base. They're both natural logs, means the base is e. So I can just work with what's inside. X squared plus x minus 6 equals 14. So I'm going to bring that 14 over so I can factor. X squared plus x minus 20 equals 0. So we're looking for what two numbers multiply to negative 20, and those same two numbers add to 1. So if I use 5 and 4, and the 4 is negative, it will work. So x plus 5 times x minus 4 is equal to 0. So x plus 5 equals 0 gives me the solution of -5. And x minus 4 equals 0 gives me the solution of +4. So let's double check. The positive one should work. 4 plus 3 is 7. 4 minus 2 is 2. That one works. The negative one, if I plug in -5 plus 3, that makes -2, so that won't work. So the only answer we have here is x equals 4.